Okay. If we work out these gradients here, and I'd encourage you to double check that you're happy with this. This is 2, this is 1. That's a gradient of a half. Let's do another one here. That's 1 to the right, minus 2. By definition, that is a gradient of minus 2. These are at right angles. What do you notice about their gradients when the lines are at right angles? Well, they multiply to give minus 1. Or if you want another way of describing it, is they are the negative reciprocals of each other. These ones over here, if I just reveal for you, you can see that pattern as well. So when you have perpendicular lines, that means when they're at right angles to each other, this relationship will be true. So 3 goes with minus 1 over 3. Minus 2 goes with 1 over 2. Show you some more examples. 5 goes with minus a fifth, because 5 is actually like that. Minus 2 over 3 goes to 3 over 2. The signs change. One's positive, one's negative. It must be, otherwise how would it make that right angle? It just wouldn't, would it? Okay, and the numerator and the denominator swap. So 2 ways you can write this. You could write this sort of as a perpendicular, a negative reciprocal. So for example, a half is the same as minus 1 over the other line, which might be, for example, like minus 2. Okay, minus 2. Or another way that you might want to think of it is that the gradients multiplied together to give minus 1. However you want to think of it, just check that you're happy that you can derive these results here. So this holds for when we have perpendicular lines, the gradients will be negative reciprocals to each other. Notice how I'm only talking about the gradients. I'm not talking about anything else because we don't know about anything else at all. Okay, so parallel lines are equal, perpendicular lines are the negative reciprocal. A couple of questions. So a line goes through 9, 10. So that's like an x, one, y1. And it's perpendicular to another line with this equation. So what's the equation of the line? Well, if it's perpendicular to this one, so I'm not actually interested in this one, I'm just interested in its gradient, then the gradient of the line I'm interested in must be 1 over 3. Because it's perpendicular, and this is a fact about perpendicular. So look, I've got an m, I've got an x and a y. What I do is I write out the equation here, and I substitute the numbers in. So y minus 10 is equal to minus 1/3 of x minus 9. Okay, and I multiply it out. That will be the equation of the line that I want to find. So you use another line to help you find the line that you want to find. For the other line, the only thing I use is the gradient. I don't care about anything else because I don't know about anything else. Okay. Line 1 goes through 1, 3, and this one here. So my gut instinct tells me to just find the gradient straight away with this one. Another line is, so a second line is perpendicular to this line and passes through this. Where does line 2 cross the axis? Right. Let's talk about line 1. So I'm going to start by finding the gradient. I'm going to call it M1. Line 1, M1. The gradient, which is going to be right minus left, minus 1 minus 3, right minus left, 3 minus 1. So I get minus 4 over 2, which is minus 2. So that's the gradient of this line. The other one is perpendicular. So its gradient must be a half. Now, if I want to find the gradient of this line, sorry, the equation of this line 2, I've got its gradient, but I need a coordinate as well. A second line L2 passes through B. So look, I'm going to use that coordinate again. That coordinate is actually quite special because both of the lines go through that. So I'm using that in both of the calculations. So I'm going to use that with x1 is 3, y1 is minus 1. I plug the numbers in. Y minus y1 equals m. X minus x1. I'm doing all of this because it says, where does it cross the axis? I will only know this when I have the equation. So y minus 1 is y plus 1 equals a half of x minus 3. Where do you cross the x-axis? Where do you cross the x-axis? You cross the x-axis when y is equal to 0. So I could put that result in straight away and work through it. If the y is equal to 0, it's going to disappear. So 1 is equal to half x minus 3 times both sides by 2. 2 equals x minus 3. X is equal to 5. Okay, so it crosses at 5, 0. Finally, compare these together. If they're parallel, they have the same m. If they are perpendicular, they have the negative reciprocal. If they are neither, it's the other case. So this one has a gradient of a half. You can tell because it's written in y equals mx plus c4. How about this other one? Let's rearrange it. Put the y on the other side. Leaves you with 2x plus 4. So this one has a gradient of a half. This one has a gradient of 2. So no relationship. It has to be a half and minus 2. Negative reciprocal. This is just reciprocal. So they are not parallel. They are not perpendicular. Okay. A couple of questions to have a go at there on the board. To pause for this one here, I'll give you a hint. So this is y equals something x, and the c is 0. Pause the video and have a go. Okay, for the first one here, I'm not going to talk about this too much. There is a bit of missing working out here. So along the way, you may wish to have a bit of working out like this, which should simplify to that, and so on. This one here, this line is y equals 2x because they are at right angles to each other. If you solve these together simultaneously, you will find point A. Point A, you'll get x as 8/5. Don't forget to substitute it back in to get an x and a y, okay? When they say the point, really, they mean the coordinate. So the coordinate is 8/5, 16/5. The MAT question, we're not going to do in a video. Other ideas then. So another skill is finding the distance between two coordinates. Distance means you're actually going to find the hypotenuse. And you can do this by looking at the difference in x, which is 4, looking at the difference in y, which is 3, and doing some Pythagoras on this. So difference in x is 4, difference in y is 3. This is a 5. The distance between 2 points in general is the root of the difference in x squared plus the difference in y squared. Pythagoras, okay? It's just the same Pythagoras as from before. A couple of quick examples, 3 and 5. So the difference is 2. 4 and 7, the difference is 3. Square it, don't forget to root it. Okay, root 13. Let's do another one. 5 to 6 is 1. 1 to minus 3, what's the gap between them? 1 to 0 is 1, and then 3 more, so it's actually 4, okay? You do not need to worry about your signs for this one, because we're squaring things anyway. You're not going to get any negatives, so that's not something to worry about. 0 to minus 1 is 1, minus 2 to 3 is 5, 1 and 5, root 26. Okay, so this is about finding the distance between lines. And hopefully you'll notice that when you have the numbers 3 and 4, they make 5, 6 and 8, they make 10. These are very special cases because you don't have surds. If you do know your Pythagorean triples, 3, 4, 5, 6, 8, 10, 5, 12, 13, yeah, it will save you a lot of time because they're going to come up again and again and again, because the people who make exam papers want to make things that are nice to mark. So that's why they will use these kind of numbers. Okay, area of a shape, we've done that one before. Let's do a new one. So PQ. PQ, I'm going to find the distance of this line by finding these differences. Q. This point here is when x is 0. When x is 0, that will be a 2. just double check that you're happy with these numbers here. I'm just putting in x is 0, leaves y as 8, y is 0, leaves x as 8. I'm just quickly finding these numbers. So the length PQ, well, really, I need to know what this coordinate is to do that. So what I'm going to do is I'm going to solve them together simultaneously. If I write that as x minus 2y equals minus 4, and then I write the other one underneath with a calculator or otherwise, here I'm going to subtract. So top minus bottom, it's minus 3y minus 4 minus 8 equals minus 12. Y equals 4. I'm going to put that back in there. X equals 4. So this coordinate is 4, 4. Once I've done something like that, the rest of the question is not too difficult. What's the difference between this x value and this x value? This is 0 to 4, so it's 4. We go up from 2 to 4, so it's 2. 2 squared plus 4 squared equals root 20, okay, as we did in the previous slide. So the length of PQ, so that's the distance of root 20. Find the area of PQR. PQR is this triangle here. Now, don't do like half AB sine C if you can avoid it, because you're probably overcomplicating things. So half base times height, if you can, is what you're looking for. Now, the base and the height, base doesn't have to be horizontal. Base and height, these things just have to be at right angles to each other. So your base could actually be this distance here, from 2 to 8. So that's 6, isn't it? What's the height? Well, the height is from x is 0 to this coordinate, which is 4. So half times 6 times 4, which is the same as 3 times 4, so it's 12 square units. Okay, this is in reality more the kind of question that might come up along the way. Okay, so we tend to combine lots of the straight line questions together. Right, pause the video and have a go at the similar skills in this question here. Okay, so that will be a 6, that will be a minus 3. P you need to find with simultaneous equations. So we get 6, 3. What's the area of PQR? That's this big triangle here. So the base would be from 6 to minus 3, which is 9. What's the height? The height is 6, so half 9 times 6. What's the length PQ? So the length PQ, same as before, you want to make a dotted line here. So it's 6 across, because it's from x equals 0 to x equals 6, and it's 3 down. So 36, 9, root 45 should be your final answer. Okay, and that brings you to the end of 5EFG.